Yeah, I'm here to give you Tom and Rafa, actually, from iManage. I'm very curious what they're going to talk about, because from a certain point I'm always part of these discussions, but I've been so busy with Framework 5 that honestly I also don't know. But I do know that they've been doing quite a lot of interesting things with Axon Framework and Axon Server on a scale that is, at least for us, also very helpful to understand. So I'm pretty sure it's going to be a good story. So please give it up for Tom and Rafa.
Hi, this is getting Axon production ready at iManage. Our intention is to share some of the decisions we've made over the last 5 years when we started using Axon Framework and Axon Server. We'll share how we run our Axon applications and everything we've built around them. We hope you learn a new thing, but we also hope you come back to us and tell us a better way of doing what we are doing. After we've introduced ourselves, we'll be explaining what our company does and our product does, so that you have a better intuition of the drivers of our decisions. After that, we'll explain how we run our tech stack, given the constraints that really makes software production ready. And we'll finish summarizing the outcome of an effort we had where we wanted to understand the limits of our topology and architecture. This took us many months, many support sessions with the Axoniq team, and even on-site consultancy with them. And there's going to be hopefully times for questions at the end, and we'd like to hear your thoughts. If not during those minutes, then later in any of the breaks. I'm Rafa. I have 14 years of experience rounding up. I spent the first 6 writing ERP and sales software. I learned a lot, and I'm especially happy that I also learned what happens when you don't follow DDD. After that, I spent 2 years on a startup writing an interesting product with great technology, but that didn't sell well. And this is my 6th year here at iManage, where we build the product we show today. Outside of work, I enjoy video games and the whole world around them. And I'm sure I also share this hobby with you, just procrastination in general.
So I'm Tom. I've been at iManage quite a while now, and before that I did a couple of years at IBM after university. We have quite a globally distributed team, and after COVID a lot of us work at home quite a lot, and I've taken the opportunity to join our local fire service, which has given a whole new meaning to on-fire issues. Outside of that, we have a wife and 2 kids. I enjoy spending time with them, going out with the dogs and things, and if there's any spare time left, to play around with home automation. And I'm quite a big fan of American-style barbecue, so I'm very much looking forward to Axoniq Con 26 in Austin, in Texas. So iManage was founded 30 years ago. I went through a series of acquisitions, ultimately owned by HP, and then the management bought themselves back out again, and this year we celebrated 30 years of the company and 10 years of being independent again. During that time, another company called Raven was founded, which is where I worked, and then iManage acquired Raven in 2017. One of the products that Raven made is the origins of the product that we work on today, and we rebuilt that for the cloud, and the marketing team put a plus on the end of it as a result. So we now work on Insight Plus, and that was released with our first customer 2 years ago. Our products that we build are for law firms, big and small, or even legal departments within other companies that you might recognize the names of a bit more. Some of the products that we have, the one in the center, the Work Cloud, is the original product from 30 years ago. Obviously not in that form anymore, it's changed a lot since. But it's a document management system for law firms. So it's a bit like Git for law firms. You can do proper security and versioning of files within that. Things get organized by their projects, so a bit like a repository has many files within it. You might have many repositories in Git. They have projects or matters, as they're called in the legal world. There's a lot of security tooling that goes around that, because some of these documents are extremely sensitive with business transactions and acquisitions and things. You could make a lot of money if you had access to some of that data. Some good examples of the restraints that we have in place are to prevent conflicts of interest. We had an investor a couple of years ago, and the law firm that they use and the law firm that we use is the same law firm, and that law firm uses our products. So we were holding documents about our investor investing in our company, but we can't see the data. There's restrictions so that the lawyers from each side can't see the opposing side's documents, and all of that stands up in court as well. But that solid foundation of security allows us to then build all our AI stuff on top, making sure that we don't leak data to the wrong people. At the top, we've got Insight Plus. So work, I liken this to an IDE. When you're in a project and you're working in a project for days at a time, you know the class names, you know the variable names that are in there. You can open the file very quickly, type a few letters because you know what you're looking for. You're not browsing down the folders. You are using a limited search feature, and we call that retrieval search. You know exactly what you're looking for, and you just want to retrieve it very quickly. The thing that we work on in Insight Plus is more around exploratory search, where you maybe don't know what you're looking for. You want to find, say, a Git project that uses Spring some version, and you built a projection, and it was for a customer that I don't know, there's different parameters you can look at project level filters and document level filters. Those are sorts of problems that we're trying to solve in Insight Plus, but for lawyers. How do they find relevant information to make their next project quicker? Can't remember if I said everything I was going to say on that. So what does Insight Plus look like? This is the user interface. It's fairly standard search. It probably looks quite similar to when you're shopping on Amazon or something. You have some filters on the left and results in the middle. At the top we have type ahead. It sounds really simple, but for us it's a bit more difficult because of the security and the terms that lawyers are using. It could be company names or people names or project names that aren't necessarily in a dictionary. So we suggest things from the index, but we have to respect the security. So we're not suggesting from documents that you don't have access to. So some of the things that look really simple are actually quite difficult, and at scale of tens of millions of documents, it's quite an interesting problem to solve. On the left, you've got filters, so you can narrow down what you're looking at, whether it's document level or project level filters. And then once you've got some results, you can either do some generative AI stuff on a document or on a selection of documents, so a RAG style approach, if anyone's familiar with those. So scale-wise, when we were here 2 years ago, we had 2 regions of this deployed. We had one live customer. They had 90 million documents. That equates to about 2 billion events for us because there's several steps that documents go through. Now we have 6 regions, so a little bit bigger. We have a lot more deployments. We had 8 live customers as of last week, but we had another one this week, so that's 9 now. A few more documents and a few more users, and where we hope to be in 2 years is really ramping up the number of customers now. So not too many more regions because we're already in most of the regions that iManage sells software. But in terms of customers, we want to get much bigger. So how does a region look for us? At the top, we have our API clients and user interface clients, and they all use the same domain name, cloudmanage.com. Depending on where you are in the world, it resolves to a different IP address, which goes to one of our different cloud instances. Within that, we have our ingress, and our messages are fairly dumbly converted into an Axon message. We have a routing service that handles that, and depending on the token attached to the message, we look at who the customer is that's making the request. We know where that customer is deployed, and we can route it across our different regions as needed. And then it goes into another Axon context, which is customer specific, where our actual commands and queries are all actually executed against the data that we've got. So zooming into one region a little bit more, every region has its own Axoniq cluster of 3 primaries. They're not connected across the world, they're completely independent. It's our routing layer that is connecting the different regions globally. So we have our ingress, our multi-tenant stuff, because the requests might land in a region where the tenant is not deployed. We don't want to do those with a single tenant service because it doesn't necessarily exist in every region. So that's all multi-tenant, and our routing part shares a multi-tenant context. And then when it's in the right region, the messages is forwarded on to a tenant-specific context. So we're isolating one customer's data and their services from another one. We scale that. It's just a copy every single time. The only difference is the size of it. Some customers are bigger than others, and we scale appropriately. For the routing stuff, we didn't really want to have to update that service every time we added a new command or query. So we wrap every command and query with a kind of a routing wrapper, like nearest region or specific region. But that meant that with Axon, when you send a message, you need the class, the actual class instance, not just the class name. And so we had to play some tricks with compiling classes on the fly to make that work, which was a bit of a learning experience. Not something that we particularly like the idea of, but that's how it works. So with the tenant services, we don't show everything that we've got here. There's probably about 20 services within each tenant's area, and each of those has at least 2 instances running. So within a tenant, there are tens of services running, and if you scale that across all the tenants, we've got potentially hundreds of framework applications within each region. And across all the regions that we've got, that means we've got about 20 Axon servers and hundreds, if not thousands, of framework applications. So it's quite a complex deployment to manage. So I'm going to hand over to Rafa to talk about how we do that at scale and securely.
Mm-hmm. Okay, we run all our workloads in Kubernetes in the Azure cloud, but let's first discuss how they end up there. In Insight Plus, we fully embrace infrastructure as code and the GitOps mentality. It allows us to easily deploy to all our dev and production clusters. The Git repos contain all the information we need, the code, the deployment topology, and the configuration parameters. And we have different files describing the different environments where we can fine-tune some options, such as resource allocations, that smaller clusters are also cheaper to run. We love being able to peer review configuration changes in pull requests, because often the configuration changes are very error prone and the cause of incidents in production. Keeping our 6 production regions in sync would be a challenge without some great open source tools. Argo CD is in charge of monitoring the Git repos for changes and synchronizing the changes into Kubernetes. It calls the templating engine from Helm and applies the resulting YAMLs to Kubernetes. We do the same thing for all our workloads, including Axon Framework and Axon Server. It means we have only one CI/CD pipeline to maintain, and we can reuse it. We follow strong guidelines from our application security team and our site reliability team. As Tom said, our customers trust us with very sensitive documents, and we take security very seriously. These restrictions contribute to complexity and challenges, but that's what production readiness means. In our system, engineers don't have access to the clusters or any internal software. We only expose the parts that are guaranteed to not be sensitive through what we call a support HTTP API. This API allows us, for example, to query the event history of the aggregates, but only to the fields we are allowed to see. When engineers want to make changes to the cluster, the Git repos are the only entry point. And network access is denied by default, both to outside the cluster and between services. We apply control access rules at the network and the application layers. Our Docker images are scanned for vulnerabilities, and we patch our Kubernetes nodes and restart them very often so that the containers run on top of up-to-date software. When it comes to Kubernetes, deploying Axon Framework applications is straightforward because they are stateless and we can scale them as much as we need. But Axon Server requires persistent storage for the events and static network identities so that they can form a cluster. And we need the stateful sets for that, but they bring a few challenges. I cover that in the next slides, but basically we stick to one stateful set and 3 pods per cluster. We get many out-of-the-box features. By default, we can do rolling updates of the nodes. We can automatically spread our pods into different availability zones. We get pod disruption budgets so that we ensure there is a majority of Axon server nodes running at all times. But well, it brings some challenges. Yes, am I on the right? Yes. Okay, now that you know the deployment strategy and the security restrictions, you'll be able to understand these challenges. The first one is how we run automations. There are multiple steps involved when our customer experience team want to deploy our product to a new customer. One of them is the creation of the Axon context. The Axon server UI and API are not exposed. The credentials are automatically generated in the secret store. So manually creating them or running scripts from outside the cluster is not an option. Instead, we follow the GitOps approach. All they have to do is write the name of the context that should exist into a Git repo, and a series of automatic steps are triggered from that. First, Argo CD realizes there is a change and tries to synchronize to Kubernetes, and at that point it also runs any registered hooks. We have Kubernetes jobs registered as hooks, and those run our code. From inside the cluster, they can retrieve the secret from the secret store, and with the appropriate control access rules, it can send the request to Axon Server API to create the context. We do the same for Axon Server API tokens and to configure other third-party tools. The next challenge is that some actions in Axon Server require access to the file system. For example, if you want to create a backup, you need to execute a request, and that creates a zip file in certain location. But now you have to do something with the file. Our approach is to have a second container running on the same pod as the main container. This is what they call the sidecar pattern. This container has access to the same file system. It can request the backup, now running on localhost, and then move the generated file to a more secure, safe backup location. The next challenge is that some parts of the configuration of stateful sets is immutable, can't be changed after the initial creation. And this is especially a problem for us for something as basic as the size of the disks. We want to start with small disks and grow them as we onboard more customers and they generate more events. Our solution is to extend the Kubernetes capabilities with a custom operator. Operators are basically software very tied to the Kubernetes API. They run inside the cluster, watching for events and reacting to them. In our case, they listen to the intended size of the persistent volume, and then they request the resize to the underlying storage layer. Azure, our cloud provider, supports resizing. It's just not exposed from stateful sets. The last challenge is mentioned by the Axoniq team in their series of blog posts around how to run Axon Server, which we use as a base. The problem is that in a set of 3 pods, you cannot shut down the first or the second while having the third running. In theory, it's not required, but in practice, when you run into issues, you want to carefully manage how the pods run. Our approach is to have a way of having the container running, but without the Axon server process executed. when the container starts, it runs a script that checks whether the node should be in maintenance mode. And if it is, it doesn't start Axon server. An additional benefit of this is that because the pod is running, our SRE team could connect into it and run some commands while the disks are available. And now it's Tom's turn to continue with other aspects of production readiness, starting with storage.
Thanks. So now we've got a secure deployment. We want to switch and look at the resources that Axon server is using. We want to look at the usage of these resources, the limits that we might run into, and if there are limits that are a concern, then the actions that we want to take to mitigate that. So the first one we're going to look at is the storage. From the customer that we've had live for a couple of years, we know that every document we index takes up about 20 kilobytes of event storage in raw storage and in index space. We currently deploy one context per customer, so we isolate every customer's data from another, but they all belong to one replication group and a 3-node primary node cluster. We don't have any way of deploying extra nodes or reason to at the moment within each region. We have one disk per pod, which because of the operator Rafa talked about, we can grow that as we need to. And we did look at hot and cold storage, but we quite regularly touch old events, whether that's from sending commands to aggregates that the first event was from a long time ago, maybe there's no snapshot and we need to load those events, or we always reconcile our index with the document management system, so we're constantly going through looking, have we missed anything before, or have we accidentally deleted something since? So we're always going back to those old documents. So the limits that we've found mostly come from Azure in this case, because the disks we run in Microsoft's cloud, and the disks come from there too. There's a maximum size of 64 terabytes. So for our large customer, 100 million documents is about 2 terabytes. We could fit 30 large customers on one disk. If we want to be at 150 odd customers in a couple of years, they're not all in the same region, but that does start to concern us, and it's something that we want to understand how we can mitigate that problem, so that if we need to change anything now, we do it sooner rather than later, whilst we've got fewer customers and less data to deal with. You can attach 32 disks, but that would allow us to have 900 customers, and that's not something we expect in the next few years. Maybe in a few years we'll look at how to address that problem. And we also use a single replication group. We don't know whether that's the best plan or not, but we know that it's not good to have too many because of the overhead that a replication group brings. But before we look at the actions, we want to show you how we organize our storage on our disks. But before we do that, we're going to show you about active versus knowledge documents, because it introduces a special problem for us. So an active document is, imagine every single file in any of your Git repositories, every Java file, POM file, documentation you've got in there, any other resources, tests. They're organized by project, but you could have thousands of these, millions of these across all of your different repositories. They could be old and untouched and not maintained. They could be brand new and well maintained. It could be literally anything created by anyone at any time. A knowledge document is, especially in Europe, law firms quite frequently have a knowledge management team, and their sole purpose is not to work on client work, but to maintain a curated set of documents with the latest laws applied and good metadata on them, and they're actively keeping those up to date as things change. You could imagine the analogy for us is that you have a template project. I don't know if anyone has template projects. We don't. We tried. We didn't maintain it. We didn't have a team that were dedicated to keeping it up to date. But if you did, those template projects, they're much fewer in number. The scale for us is about 1,000, tens of thousands of knowledge documents for a customer versus tens of millions of active documents. So 1,000 times increase if they go from knowledge to active. The first features we released were just around knowledge, and the features we're looking at now will require a full index of all of those active documents. So we're seeing that some customers, they start with knowledge and then they go to active. So they go from small and they go to very, very big. So how does our storage grow over time? We're going to use a popcorn analogy here, but we have general day-to-day increases. That customer that was 90 million 2 years ago is 97 million today. You could imagine that the popcorn kernels that you're putting in the pan just get slightly bigger. If you left it long enough, your pan would get fuller, and eventually maybe one day you need a slightly bigger pan. We'd need a slightly bigger disk. We add new customers. It's like pouring more kernels into the pan. At some point you might say, that pan looks pretty full, I'm going to start a new one. For us, that's 1 customer a couple of years ago, 9 today, 150 odd hopefully in a couple of years. But the problem for us is when those customers
Oh, not working.
go from go from knowledge to active. So these existing customers that we've got placed on the disk suddenly start to take 1,000 times more space. That's when the kernels start to pop. And if you've overflowed your pan, now everything's falling out of your pan and making a complete mess. Random analogy over. So if we onboard a new region, it has no customers to start with. The first customer we put in might just be knowledge, and so K for knowledge and 1 for the first customer. We add a second customer, and then we add, say the third customer comes along and they want the full active index from day 1. The sizes here aren't really comparable. They would be 1,000 times bigger than the ones next to them, but that wouldn't make a very nice diagram. We add a couple more, and say that's it, we've finished onboarding customers for a little bit. What happens when one of these customers goes from knowledge to active? Suddenly we start to take up a lot more room. That's okay, we've still got available space, we've still got some buffer, but when the rest of them do the same, now we've got a problem, and this is the problem that we want to try and solve. We've used all our available space, and we've started going into our buffer, and we're at risk of completely filling that disk and not being able to write any more events. So how can we deal with this? One solution is that we just move one context off to another disk. We get back our available space and everything's fine. But actually this is really hard when you're following GitOps. You can't just move a context. If we don't have access to those machines, our SRE team could do it, but they'd have to remove the context, leaving the data, move the data, and then re-add the context at the new location. That means downtime. We don't really like that approach. So our next solution was that as we onboard customers, we just reserve some space for them. When we've onboarded the first 4 customers, we're now getting towards our disk being fully allocated, not used, but allocated. So when the 5th customer comes along, we start a second disk because their reserved space wouldn't fit in the available space of disk 1, so they have to go on the next disk. This would work, but we are starting a new disk when the previous one is barely used. If we didn't have any active documents, active customers on the first disk, our disk usage would be 1,000th of what the disk could actually hold. So if we can be at 64 terabytes, we're only at 64 gigabytes when we're moving to the next disk. We would be using a lot more disks than we really needed, and our SRE team don't really like that because there's a limit to how many we can mount, and we're running pods on nodes that are shared with other applications that might also need disks. So the solution we've come up with is to use Axon servers tiers. When we get into this situation, probably we'll do this before we get to this situation, but if we got to this situation, we would configure a second tier for one context. We, as engineering, would choose which one that's going to be. We can apply that as a config change in Git, which our hooks pick up and apply into Axon server. Once that second tier is defined with a size limit on the first tier, Axon server would start moving the events over to the second tier, and when that's done, we've still got the first tier on the first disk, but now we've reduced that usage on the first disk, and we've gained back our available space in all of our buffer. So this solution, we are not using new disks when they're barely used. It is a bit more complex for us to manage, but it solves the downsides of the previous 2 approaches. So back to our actions that we're going to take. Our action will be that we will use new disks as needed. We've decided that we'll have one replication group per disk, just so we don't have all our contexts in one group. We can segregate them a little bit. And we also want to look at other ways of reducing usage in the first place. So we've looked at CBOR serialization instead of JSON, although the analytics stuff does not support JSON, so maybe we want to review that decision. We have looked at deleting some legacy events, but as everyone here probably knows, that's and summarization was a feature that we looked at. But that's something that we analysed our old events and worked out we wouldn't actually gain much from. So we're not looking at that at the moment, maybe one for the future. But that's everything on storage. I'm going to hand over to Rafa to talk about the rest of the resources that we looked at.
Okay, yes, the following set of slides shows some numbers of the message processing rate that we could achieve with a similar configuration to what we ran in production. our goal was not to stress test Axon or run benchmarks, but just to understand our limits and any obvious bottleneck. In the setup we had 3 Axon nodes and then many clients dispatching as many messages as they could, and many handlers doing nothing because we were not interested in measuring our domain logic. In each section we use our expected usage, the measured numbers in the tests, and any applicable actions that would improve or mitigate any issues. In terms of commands and events, we need to publish around 200 events per second per tenant. This is mostly in the initial crawl of all the documents from our customers. We have other hard blockers that we can't scale, so we don't need much more throughput than this. We measured we could achieve 60,000 commands per second, and after this we couldn't vertically or horizontally scale the handlers. The bottleneck was inside Axon server itself, where threading and locking is involved. Of course, writing the events was much more slower. We could achieve 15,000 events per second, but we are happy with the results. We can limit the number of tenants we onboard simultaneously, so it's not an issue for us. In terms of queries, the bulk comes again during the initial crawl, where we do some processing of the documents. The search requests from end users also come as queries, but they are much smaller than this automatic process. The results were more interesting. We saw we could achieve a similar amount of messages per second, but the performance was degrading while we added more query handlers. We reported it to the Axoniq team, and they improved the problem. The issue was that Axon server tracks the duration metrics of the query handlers, so that subsequent messages are sent to the most efficient instance. But tracking the metrics start to become expensive when there are many messages concurrently. They improved their performance, but we don't need it. We don't have any use case for it, so we disable it entirely with those configuration parameters. In terms of event processing, again, the critical moment is during the initial crawl. We need we have several event processors reading the 200 event per second. That's 200 event per second that we generate, and rounding up, we need to read around 1,000 events per second. For this test, we ran several iterations with many JVM instances independently using in-memory token stores. We found that 200 event processors were able to read 650,000 events per second. Again, happy with the results. If we needed more throughput, we could reduce the number of segments or limit the tenants we onboard simultaneously. Changing the theme a little bit, we found that in terms of resource usage, our biggest constraint is the global index that Axon server maintains. This index is what allows Axon server to quickly find the location on disk of all the events belonging to one aggregate, which is why memory usage increases with the number of total aggregates, not with the number of events. The index is used very often, and it's best to have it available in memory. When it doesn't fit into memory, it has to read from disk, and the impact is clearly noticeable. With the current default implementation of the index, there is no workaround for that except to keep increasing allocated memory. But in Axon Server 2025, with support to DCB, the Axoniq team is releasing a new implementation of the index with massive performance improvements. We are looking forward for that. And also related to the global index, another aspect to improve we found was that at some point Axon server was starting to take 15 minutes to initialize, to fully become available and start participating in the consensus algorithm. We reported again to the Axon team and they mitigated the problem with a feature. The problem was that when the node is initializing and at the same time events are being published, it leads to reading the same blocks on disks multiple times. This configuration setting makes Axon server preload the entire index into memory. Instead of lazily loading while initializing, it blocks until it has read the entire index. The startup time was reduced from those almost 15 minutes to less than 4. And that's all the content we have for you today.
So thank you for listening. We're pretty happy now that we've got a secure and scalable Axon server deployment that will scale as our customers grow. Downside for Axon is we haven't had to buy any new nodes to do that. But yeah, if you've got any questions, we're happy to take them now. I think we've got a couple of minutes left. Otherwise, come and find us at the breaks or after at the end of the day. Thank you.
Thank you. Thank you.
Thank you. Very impressive what you've shown. I have one question. You actually on your slides you're taking you are speaking about production nodes. So you have the 3 node clusters all the time. Are you using only like active production? Don't you use backup nodes and all this stuff that is available?
We don't.
No, we don't, because we've got 3 replicas of the data. We're happy with that as a high availability solution that gives us enough resiliency that we don't need to take a backup as well. Although we do back up some of the index files.
We back up the replication logs and the control DB. Having another copy of the entire event store would be expensive. It's a trade-off.
Yeah, and I guess we're crawling the documents from the document management system, so if there really was a huge disaster, that data is not, we're not the system of record, so it's less, yeah.
Yeah, just a question on the Axon server deployment. So for the multi-tenants, you show that you basically duplicate all the service deployments per tenant, but do you just use one Axon server cluster, or do you also duplicate the Axon clusters, the server?
It's one shared cluster, but every tenant has their own context. So the data is isolated, but the messaging framework, I guess, is shared between all the tenants.
We are using Axon contexts as a way of isolating our customers and not really as bounded contexts.
Yeah.
Yeah, excellent presentation. Thanks for the honesty. It's really, really insightful. How much day-to-day work do you think your company or team does with Axon server? Is there a team? Are you to the team? Like, and that's all you do is look after the servers, or is there, less work involved day to day?
So I'm more of in an architect role, but Rafa and a couple of other guys, you are the team that look after Axon server, but also a lot of other stuff at the same time. So it's half a person is probably on average how much effort we put into Axon server. I mean, it was a lot more at the beginning when we were setting things up and learning everything, and
exactly.
I think now we're in
or running all these tests to get these metrics we showed today.
Yeah,
but
I
a
think
lot of time.
Now we're in a good place, and it kind of looks after itself at the moment. So. Yeah.
Thank you for the great presentation. I have a question about the legacy events. Can you throw some light on it? How are you dealing with them? Are you deleting them or maintaining?
We ran an event transformation to delete them. It doesn't completely delete them. It deletes the payload, but some of the metadata remains. So we've cleaned up some space, but not not all the space. We did toy around with having a black hole tier, which is where the summarization idea comes in, because we can't delete events of old aggregates, so we could rewrite those, refresh them, and then delete all the old events. Maybe that's something we'll do in the future. We haven't decided yet.
There's another tool we built for that. Instead of doing one huge event transformation, we make smaller event transformations, and we have a service with a state machine doing all those transformation and making sure it doesn't. It continues and doesn't get stuck.
I believe we're out of time. So, thanks again, Tom and Rafa. It was awesome. I really enjoyed it. So, last hands up for them. Yeah.
Thank you.
Thank you.